Deliveroo, as they say on their website, restaurant food, takeaway, and groceries delivered. You get your food delivered in a flash. You can see when your rider's got your order. It is a world-class operation. Now, Deliveroo is known for its fast service. It's in markets around the world. And interestingly enough is the engineering story behind it. Joining me today are two engineers from Deliveroo, Felix Angell and Duke Ku. Felix is a software engineer and Duke is a senior software engineer at Deliveroo. And what they're going to talk to us about is like what it's like to run this real-time service that's used by hundreds of thousands of customers. Now, Deliveroo works very closely with Amazon Web Services. They deliver a service that works simultaneously to complete hundreds of thousands of orders across the globe. And that's where AWS managed service from Apache Flink really comes into play. What Deliveroo has done is built a real-time streaming application using Apache Flink. And if you're not familiar with Apache Flink, it's an open source unified stream processing and batch processing framework developed by the Apache Software Foundation. Now, the Amazon managed service for Apache Flink is accessible to customers who are building services like Deliveroo or just are looking for that way to easily deploy Apache Flink applications and get those actionable insights. So we're going to hear about Deliveroo, not as much as about getting some chicken nuggets or some French fries, but more so the engineering and how that serves as the foundation for their intuitive system that's reliable for riders to deliver the food, the restaurants to prepare it, and the grocery stores that supply customers. So thank you very much, Felix and Duke, for joining us. I really look forward to this conversation.
Thank you for having us.
Yeah, thank you.
So the first question I really have is about the people who use Deliveroo. Many people will be familiar with the Deliveroo riders. Perhaps you can tell us a bit about who you are, the team that you work on, and your roles at Deliveroo. Duke?
Sure. My name is Duke Angell. I'm a senior software engineer at Deliveroo. I'm at the team called messaging platform actually. So the platform, we look after Apache Kafka within Deliveroo, and we build services and tooling around the Kafka ecosystem.
Excellent. Felix?
Yeah, hi. Yeah, I'm on the same team as Duke, so I'm also on the messaging team. Yeah, I'm a software engineer. I've worked here for a year and a half. And yeah, I guess, we look at Kafka, look after it, build stuff around it. And I guess, today we're going to be talking about what we've been doing with Flink for the last year or so.
Yeah, I'd love to hear about that. But can you, first of all, talk about the use cases? I'm very curious about that. How that, works with the work you do and the support that you provide.
Sure. So as a platform team, we've been asked by other engineers within Deliveroo, as well as existing use cases within the organization about a near real-time stateful processing capability. We already have this sort of capability within Deliveroo, but this tend to be bespoke application built on top of streaming frameworks for various languages. However, a abstract, a generalized mechanism is missing. So the team, as a team, we have looked into various technologies and also look into the use cases within Deliveroo. And in the end, we pick one of the use case and use that use case to trial Apache Flink. Felix, you want to chat about the use case in details?
Yeah, sure. So Deliveroo, we're a food delivery company. We have a three-sided marketplace. We have riders, restaurants, and then customers who place orders on the application, to get food delivered to their door, or groceries. And so the one use case that we looked at here was like focused on the customer side, and mainly around kind of looking at customer behaviors on the application and processing that in real time to build, say, a customer journey of how they use the application. So as a customer, you would produce like a click stream of events, be it on the app or the website. And this could be like you'll serve the homepage, or you're adding an item to your basket. Maybe you're checking out, or you've placed an order. And from these events, this drives a lot of our downstream systems. So things like what experiments we run, the business strategy, product analytics, and everything like that. We have a system, kind of as Duke mentioned, around sessionizing these into groups of activity that we analyze, and we wanted to look into this with Flink and replace that legacy system with something a bit more stable and that would work in the long term. And that's kind of the main use case is this click stream of events and sessionizing them.
What makes Flink a little bit more modern, I guess, for lack of a better word?
Yeah, so I guess just to touch on that. So the prior solution, Duke knows a lot more about it than I do, but so we look for something with kind of more feature parity, but Flink is like a streaming engine that is kind of designed around these like well-defined concepts and processes in like doing stateful operations over streams, whereas our existing solution is very bespoke, kind of only handles a few inputs, outputs, and like operations. Duke, I don't know if there's anything more you want to elaborate on with the system in particular.
I think the thing that Flink is more modernized than what we had is just a generic streaming engine that we can leverage for many use cases, whereas the solution that we have is built bespokely and tailor-made for only one use case, for this particular use case.
Right, that makes a lot of sense. And so when did you first hear about Apache Flink?
So we first heard about Apache Flink about 18 months ago. So initially, the problem that we had was the legacy system was start to degrade, and we look into scaling the system up or out, and it turns out that we can only scale it up. And as we scaled up, because of some of the technology choice in that legacy system, we cannot scale it down. So we couldn't have auto scaling for that legacy system, and that means even if you think about our traffic is very time sensitive. So when people ordering food, it's usually around lunchtime, dinner time, and this costs this become a requirement for us to scale the system up to a point to be able to handle the high load. But when, let's say, around nighttime, when the load is very, very low, that means the system cannot be scaled down, and we end up spending a lot of money on this legacy system. So as a result, we start thinking about decommissioning this legacy system and start looking for a replacement. And when we start look around, then we have a couple of choices for stateful streaming frameworks. So, for example, Spark, Kafka Streams, and Flink. And and if you look at these technologies, Flink shine out the most because this is being used by dominant companies out there. Is production ready out of the box. So that it seems quite promising when we first approach it, and it's also provide all the feature parity compared to our legacy application.
So there was a real cost savings there. That's really interesting. So after looking at all that, why do you think Flink would be a good fit? It seems like, there's other options that you could consider, such as batch-based solutions, rather than streaming. So why not just do that?
Yeah, that's a great question. I think so. To answer the question about batching and streaming, I think it's quite simple because our legacy system is already handling this event in a near real-time streaming manner. So we need a solution for feature parity. However, streaming is the future, and we want something more future-proof so that even though once we fulfill this use case, we would be able to replicate the use case and introduce Flink to the wider engineers within the organization. If we compare it to other streaming framework as well, so for example, Kafka Streams, Flink, one of the reasons that I really like Flink is the separation of concerns. So as opposed to Flink, Kafka Streams leverage Kafka durability, and it's just become like a thin wrapper, a library, and rely on Kafka heavily. However, as the opposite, Flink is more self-contained. All the durability is built in within Flink, so we have a better separation of concerns. And additionally, Flink provides integrations with other technologies like Kafka, S3, Kinesis, Elasticsearch by the connectors.
So those connectors really played an interesting part in that. I'm also then curious about how it fits into your use case. How does Flink fit into your use case? And maybe you could take us through, your architecture.
Yeah, I can take this one. So I guess architecture-wise, so with our clickstream of events, those are like our inputs, right? That comes from Kafka and Kinesis, and then they're published from hundreds of services, and then like a big monolith as well. The Flink application itself, there's kind of one big app, big job that processes all of these events and does the sessionization. That consumes from the two sources, so Kafka and Kinesis. And then we group these events into sessions, and it's based on a period of 30 minutes of inactivity. So if you're on the app and you're using the application and you're publishing events, from your activities, if there's like a 30-minute gap, we'll slice a new session for that particular customer, right? And rather than aggregate these events, which is I think how Flink would approach it out of the box, we apply a session ID over each individual event. And this gets performed as like over events and over sessions for the customer. But also we do this across devices too. So we kind of perform this again over multiple devices. So if you're on the website and then you're on the app, the sessions are kind of the same as long as they're within that window of time. These events get written into an S3 bucket, partitioned by date and time. And that's where we load it into like our data warehouse for analysis. And that's kind of where we drive a lot of our business decisions and like all these kind of things that we use for looking into like customer journeys on the app. And then interestingly with Flink, we use Python. So we use PyFlink, which is basically a way of defining the kind of the job DSL for your stream processing kind of functions and the whole application, I guess. And we do have a bit of glue code in Java as well for like serialization, deserialization, these kind of things.
So you have chosen to use the AWS managed service. And I'm very curious about that, from your perspective on, what it provided for you as a proof of concept on Kubernetes, how it supported things like PyFlink. And I'd also like to just get into, how, you worked with it from idea to production. So, how did you think about multi-language applications? How did you think about Terraform? what were the dev stage cycles that you thought about? Could you provide some commentary? So first on, why you chose AWS managed service, and then a bit about the journey.
Sure. So initially, we start experimenting with this as a POC on Kubernetes, and at that point in time, the Kubernetes Flink operator wasn't a thing, and many other third-party operator were just a little bit not supported, not well maintained. That's why, and then that's why we decided to go for a managed service. So to offload that burden of maintaining, operating Flink application to a managed service like MSF. And around the journey from ideas to production, the moment we decided that we're going to use a managed service, then that means that we just need to handle the rest. So the rest is that building the application, make it CI/CD, and test it, and then take it to production. So that's where we leveraging that what we already know, the way we can deploy a Flink application is just very similar to a Lambda zip it up, upload to an S3 bucket. And CI/CD, we're already using Terraform to make everything automated, and testing and all that sort of stuff are all automated. And that's how we took our ideas from an ideation to POC and then to productionize it.
Excellent. So let's get into some of the challenges that you've seen with using Flink. And also, I'd love to know a little bit about, what have been, the upsides to it. What have been really the benefits for it? I know that on the, challenges, there's all kinds of things that can happen. Alignment issues, a Windows functionality. I understand that was an issue. Design, the dev cycle. What are some of the major challenges you saw? And then what were some of the key benefits that came up for you?
Yeah, so I think when it comes to challenge, this comes from three areas. It's come from Flink, it's come from PyFlink, and it's comes from MSF. So I was just going to pick top three for me. And for me, top three for Flink is going to be the challenge between handling a slow stream and a fast stream. So let's say if you have multiple sources and one is slow and one is fast, watermarking alignment can be very challenging. For PyFlink is the additional resources constraints that we have for Python and JVM. And when it comes to MSF, the challenge was low-level configuration are not very flexible. The auto-scaling was also very, very strict. Felix, do you want to talk about your top three?
Yeah, sure. So yeah, I guess kind of same with Duke. Though for me, I'd say a big one that maybe is not mentioned is PyFlink and M1 support was a little bit tricky at the time. I think M1 is generally just an issue when you're a developer sometimes. But yeah, we were pinned to a particular version of Flink, which the dependency was not yet ported for M1. So we had to use GitHub Codespaces for some of the development in that case. And then, I'd probably echo the slow fast stream was led to a few tricky bugs to kind of figure out.
I guess on the upside, right? For me, the biggest one would be the simplification from a bespoke distributed system design, moving all that complexity into application level. And because it's a framework, it's also an engine that it's just make that abstraction very powerful. And basically, when we have less moving parts, we have less friction and just make your application more durable and more resilient.
Yeah, absolutely. Same for me. I think it lets you just focus on kind of building out the, doing the business logic more so than worrying about your infrastructural concerns. And then having the community, I think, is a big one too. So like the Flink Slack channel, of which a lot of the AWS developers were on there too to help is always really nice. So we had a lot of help from
That's nice, isn't
just
it?
the community.
That's
Yeah,
really
it's great.
helpful. Yeah, to have that support. So I think in conclusion, I'd like to know kind of what are your next steps for using the managed service, the Flink managed service from Amazon, and how you're thinking about that at Deliveroo, and then what are some of the features you'd like to see from AWS, their managed service for.
Yeah, I think for the vision, so pretty much taking our learnings over the last year or so of using it, and we'd like to see if we could enable more teams at Deliveroo to use Flink as well. So basically, taking our learnings, packaging it into like a useful kind of repeatable process for other teams that want to take advantage of near real-time streaming in like their data pipelines and so on. It's probably a big one for me with the vision. Maybe feature requests. It'd be nice to have zero downtime deployments. It's pretty the downtime is very minimal, and it's like a function of like how your app performs. But there's still kind of lag at the end of the day, so it'd be nice to maybe have more flexibility with that, or being able to like switch across applications. I guess that's probably a long shot. Duke, how about you?
I think for me, one of the vision can be, because within Deliveroo we move very fast to roll the latest product to the market, and that means our modeling sometimes can be a little bit we'll need to be flexible to adapt to that demand, and the data modeling flexibility comes with a cost where sometimes you need to remodel things. So sometimes you need to normalize or denormalize the model of the data. And with Apache Flink, that would help make that process easier for teams to do. And for me, one of the features that we'd like to see is a self-serve configuration from MSF, so that we can just tweak some of the low-level configuration as well as auto-scaling requirements based on application metrics.
Well, I want to thank you both for taking the time to talk a little bit about Deliveroo and how it's using Amazon Web Services managed service for Apache Flink. I've learned a lot about your use cases, the work you're doing, and the support that you're doing individually. How you first heard about Apache Flink, how it's a good fit, the use cases. There's a lot here. So thank you very much for your time, both Felix and Duke. I really appreciate it.
Thank you for having us.
Yeah, thank you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.